Use a graphing calculator to sketch the graph of rah, 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 rah. Okay. Let's see here. Here is a graphing calculator, and on it we have to put x squared minus 3x minus 18. Graph. Okay, we knew it would be a parabola and that it would open up. What does it have for zeros? Just following the tick marks, it looks like it has a 0 at -3 and another one at 1, 2, 3, 4, 5, 6. So the zeros of the function are -3 and 6. You can verify that with a table of values if you like. The y-intercept, this is trouble. The y-intercept is not showing on this graph. My window is a little small here. So if you hit window, we want to see lower on the graph, which means we want our y minimum to go down further. If I make that -20 instead of -10, let's see if that helps. Okay, well, you could try to count those tick marks and go blind doing it, or the other way that you can do this on the calculator is to go second trace, and the first option, value, lets you just plug in any number you wish. If you want the y-intercept of a function, you're asking where is it when x equals 0, and then you get a quick accurate answer. The y-intercept is -18. Coordinates of the vertex, I knew I'd get in trouble with this. This window doesn't quite show the vertex. It's clipped off at the bottom, so even -20 is not low enough. Let's make that 25 and see what we get. Okay, that ought to do. So the coordinates of the vertex are second trace. You're looking for a minimum this time, the lowest point on this curve. And now it wants to know, you need to tell it where to look for a minimum. And so it says left bound, and you've got this little flashing bug here. Put that a little bit to the left of the minimum point you're trying to find. Hit enter. It puts a little triangle up here saying, okay, that's the left bound. Now it says, where's the right bound? Move the little bug with the arrow keys until it's just off to the right of the minimum you want to find. Hit enter. Now you've got two marks here saying, I'm going to search in this region to try to find a minimum. Now it asks if you have a guess where that minimum value is, and it doesn't really matter what you do here. Just hit enter, and it thinks for a moment, and it says when x is 1.5, the y-coordinate is -20.25, and that's the lowest this curve gets. And it moves the flashing bug to that point in case you want to confirm you've got the right one. So those are the coordinates of our vertex. And for the domain and range, let's get out of this for a minute. We found our zeros were -3 and 6. The y-intercept was -18. The vertex was at 1.5, comma, -20.25. The domain of a quadratic function is any real number, because just like with the lines we've seen, it goes forever to the left and forever to the right. So x can be any element of the reals. For the range, we've seen that -20.25 is the lowest this curve ever gets. It can be anything higher than that. It'll rise forever, but it doesn't fall forever. It bottoms out at -20.25, and that's all. So for the range, you could say y can be any real number, comma, except, y is always greater than or at least equal to -20.25. Some teachers aren't worried about the YER part. They'll just take the y is greater than or equal to. That's fine. I was taught to always put this in, and I do it out of habit now. Now, getting away from the calculator a bit, they say use factoring to determine the zeros. If you have x squared minus 3x minus 18, that factors as x minus 6, x plus 3. And so if we're trying to find zeros for this thing, we want to know when it equals 0. We can either solve the first factor, x minus 6 equals 0, which tells us that x could be 6, or solve the second factor, and that quickly leads to x could be -3. Same thing the calculator found for the zeros of the function, but we do it by factoring. And finally, rewrite the equation of this graph in standard form. Do you remember completing the square? That's how you take a quadratic and turn it into standard form. In other words, we've got y equals x squared minus 3x minus 18. And we want to get that into a form that looks like a x minus p squared plus q. Or if you learned x minus h squared plus k, that's the same thing. So the way we do this is completing the square, and it consists of, first, if there were a coefficient in front of this x squared term, we'd factor it out. But there isn't, so we get a break there. And your next step is separate out the first two terms. We have x squared minus 3x. Just put brackets around those and leave a bunch of empty space after the minus 3x. We're going to do some stuff in here. The minus 18 just got frozen out. We want that out of the way for what's going to happen next. Now, the next step is take this coefficient on the x term, negative 3, divide it by 2, that gives you minus 1.5, and then square that. That gets you 2.25. So take this number, cut it in half, square the result. You're going to take that number and add it in here, 2.25. Now, because you can't just magically add a number anytime you want to balance that out, we're also going to subtract 2.25. Okay? Now, overall, I haven't changed anything. This is like taking 225 out of the cash register, but leaving a note saying, I owe you 225. Technically, you've kept things in balance by doing that. And this equation's value hasn't changed because I've got these numbers canceling each other out. Why do we do that? Because we're going to separate out these first three terms. Your next line, we're going to take x squared minus 3x plus 225. And then we have our minus 225. We're kind of kicking it out of those brackets, but we still have it, so we're okay. And then we have minus 18. We're almost there. Last things that happen, we factor this part. We've got a trinomial here, and you'll find if you factor it, it's actually x minus 1.5 all squared. Try foiling that out. You'll see that it produces x squared minus 3x plus 2.25. You can get this number by either taking the minus 3 and cutting it in half, or by square rooting 2.25. Either way, you'll get 1.5 as a result. These two numbers on the end, we squish together, and we get minus 20.25. And now we're there. We're in standard form. We've got an a, which is this invisible 1 out front. We have a p, which is our 1.5, and we have a q, which is our 20.25. P and Q tell you the location of your vertex. The vertex is at 1.5, comma, minus 20.25, and again, that's the exact same thing the calculator told us.